Hello everyone, I am Dr. Sina Shamekhi and this is the first session of the Bioinstrumentation course and we want to start the lecture 1, Introduction to Bioinstrumentation. First of all, let us to review the definitions of instrument, bioinstrument, and also the basic objects of bioinstrumentation. As you can see, in Merriam-Webster dictionary, we have two main definitions for instrument. A tool or device used for a particular purpose, especially a tool or device designed to do careful and exact work. As you can see, we are talking about some exact work here to have an instrument. In other definition of instrument, as you can see, an instrument is a device that measures something such as temperature or distance. But bioinstrumentation in Merriam-Webster dictionary is used to some parameters or physiological data from a live or a human body or something like that. As you can see here, the development and use of instruments for recording and transmitting physiological data. Therefore, a bioinstrumentation device is an instrument which is used for recording and transmitting physiological data. And the basic objective of the bioinstrumentation is for information gathering, diagnosis, evaluation, monitoring, and control. And we will discuss about these objectives in the next slides. The first objective was information gathering. As you can see in the system, machine is used to measure natural phenomena or other variables to aid man in his research for the knowledge about himself and the universe in which he lives. In this setting, the characteristic of the measurement may not be known in advance. Also, we want to gather some information about the body, about the physiological data, to make some decisions, some diagnosis, and therefore some decisions. The next objective is the diagnosis. Measurements are made to help the detection and the correction of some malfunction of the system being measured. The system could be a human body also, or a device. And we want to gather some information to diagnose the malfunction of the system. In some application, this type of instrumentation may be classed as troubleshooting equipments. The next objective of the bioinstrumentation is the evaluation. Measurements are used to determine the ability of the system to meet its functional requirement. The assessment or evaluation of the performance of the system is another main objective of the bioinstrumentation. In some cases, this could be classified as proof of performance or quality control. Maybe you hear something like QC in fabrication in some uh, in some uh, fabrications of devices, you can see a part to give QC to the devices. QC means that they control the ability, the performance of the system, and they sign it as a only two-word label, QC, and it means that evaluation is good. Other objective of the instrumentation, bioinstrumentation, is monitoring. Instrumentation is used to monitor some process or operation in order to obtain continuous or periodic information about the state of the system being measured. As I mentioned before, the system can be our body, and monitoring our body means that we want to monitor the situation, the parameters, the main vital signs of the body, such as temperature, heart rate, or other vital signs to control, to diagnose, to control. And as you can see, the last objective of the bioinstrumentation is control it. Instrumentation is sometimes used to automatically control the operation of a system based on change in one or more the internal parameters or in the output of the system. We want to control the temperature body. We measure it and we want to control it. We measure the blood pressure and we want to control it. Therefore, bioinstrumentation helps us to gather information, to diagnosis, to evaluate. Therefore, after evaluation, monitoring, and after that we can control as a fixed parameter or to control the situation in a good state. In this slide, we have a block diagram about generalized instrumentation system. As you can see, we have some parts here and some connection. Some solid lines connects these parts and some dashed lines connect these parts together. Solid lines means that these parts connected using solid line is essential for an instrumentation system, and dashed lines means that the parts connected using these dashed lines is not necessary, is not basic. And in some devices we have these parts, and some other systems we don't have these parts. Let us to check all of these parts step by step. The first one is the measurand. The measurand is a parameter we measure it. The second one is primary sensing element and variable conversion element. As you can see, we call sensor to these two parts of instrumentation system. After that, the data generated by the sensor goes to signal processing part, and after that we can display the output of the signal processing part in a display. Also, you can see some other parts like calibration signal, like data storage and data transmission part, and also control and feedback. Control and feedback used to some parameters like pressure, like temperature. For example, we want to control the pressure of the blood using some medicine. Also control of the blood sugar. We measure it and we control it. And also, as you can see, we have some power source here. We use these power source to drive some sensors, some electronic parts, devices in our instrumentation system. And also the last part is this part, is some measuring systems, measurement systems. We use some applied energy. Applied energy such as a radiation, electric current, or other applied energy used to excite, to generate some measurements are generated normally in the body, like temperature, like blood pressure, but some other measurements such as MRI images, CT scan images, X-ray images, sonography or ultrasonic images need some applied energy from out of the body, and we use these applied energy to excite, to generate that measurement from the body. The first part of that block diagram was measurement, and as you can see, the definition of the measurement is the physical quantity, property, or condition that the system measures is called measurement. As you can see, physical quantity, property, or condition. Based on accessibility, we can categorize measurement to these categories: internal measurement, such as blood pressure; surface recordings, like ECG, electrocardiogram; emanate as infrared rays, infrared waves, and also tissue samples can be a type of measurements. And some most medically important measurements are biopotentials like EXG, ECG, EEG, EOG, EMG, and also other EXG biopotential signals: pressure, flow of blood, flow of air, flow of liquids inside our body. Dimensions is other important measurements is another important measurements used to use in some imaging methods like sonography or other types of imaging. Displacement, as you can see, velocity, acceleration, or force is some measurements extracted from displacement. Temperature, we talk about it, and also the chemical concentration of some ions inside our body. I should emphasize that the measurand may be localized to a specific organ or anatomical structure. In other words, when we are planning to measure a measurand inside our body, we should focus on the location of that recording, and we should fabricate, we should design and fabricate a specific sensor to record a specific organ or anatomical structure. The next part of that block diagram was the sensor. And first of all, we should review the definitions of some words: transducer, sensor, and actuator. As you can see, transducer is defined as a device that converts one form of energy to another. It means all type of energy can be converted to another type of energy. And we call transducer to such a device. But the sensor converts a physical measurement to an electric output. As you can see, we have a type of energy here, another type of energy here also. Therefore, a sensor is a transducer. A sensor is a specific type of transducer. An actuator converts an electrical input to physical output. The reverse way of the sensor. Electric output was the output of the sensor, and here the electrical signal is the input of the actuator, and the physical signals, physical data was the input of the sensor, and here physical output or physical signals are the output of the actuator. Actuator like speakers, like motors, armatures. These are actuator, and sensors are some transducer, converts a physical measurement to an electric output, such as temperature sensors, distance sensors, infrared sensors. And also, as you can see, in actuator, we convert a type of energy, electric input, to another type of energy, physical output. Therefore, actuator also is a transducer. But actuator is not a sensor, and sensor is not an actuator, but both of them are transducer. The sensor responds to the form of energy present in the measurement. We should make a sensor responds spatially to the form of energy present in the measurement. And the sensor interfaces with the living system in a way that minimizes the energy extracted while being minimally invasive. We want to measure signals from our body, and our body is unable to give us a large amount of energy. Therefore, we should minimize the energy extracted from the body using using specific sensors with minimum extraction of energy and also minimally invasive. If we can record some signal from the body, we should not design a sensor which is use some parts inside our body. Therefore, non-invasive sensors is our ideal recording methods. Many sensors have a primary sensing element such as diaphragm, which converts pressure to displacement, and also a variable conversion element such as a strain gauge converts displacement to electric voltage. Many variable conversion elements need external electric power to obtain a sensor output. We have two parts in a sensor: primary sensing element and variable conversion element. The primary sensing element is an element utilized to encounter with the measurement, with the measurand. This part should be compatible with the measurand. Compatible in impedance, compatible in size, compatible in invasive or non-invasive situations, or biocompatibility problems, issues. And after that, we use another part we call variable conversion element. Converts the output of the primary sensing element to an electric voltage. For example, in a strain gauge, we convert displacement to an electric voltage. As I mentioned before, signal conditioning is other part of, and the next one is real time and delay time mode. Some recordings record the signals in a real-time manner. We cannot detect any delay between the phenomena and the recorded signal, the recorded display. And in delay time mode, we have some delay between the recording, the real time of the recording, and the display time of the recording. For example, when we use sonography, we have some real-time device. And when we use MRI or CT scans, we have some delayed time mode because we should wait to generate the output. In the next three slides, we have some parameters or measuring techniques and related features, the range of the parameter and the frequency range of that parameter, and some method, standard sensing or recording method have been displayed. I want to review all of these parameters, and I don't want you to keep all the values in your mind, but you should be aware about these values. For example, when we are talking about the ECG, you should know the range of that voltage and its frequency band. Also for EEG, also for EGG, EMG. You are some biomedical engineers, and you need to keep in your mind the general band, the general range of the frequency of the voltage or the parameter range, because you should be able to design a good system, a well behaved system, a correct system, a suitable system, okay? Because you are bioelectric engineers and you need to be aware the general information about all of these parameters. And I want you to be aware about the general information about these tables, but the exact we don't have any questions in your exam about the exact values of these parameters.